Hi everyone. We're going to wrap up chapters 15 and 16 and talk about amine reactions as well as amide reactions. So amines behave as weak bases in water, similar to ammonia. So for example, if we have a primary amine, remember that will have one alkyl group and two hydrogens bonded. And then we have water, which will act as our acid or weak acid. So remember, water could act as an acid or a base, depending on the situation. So what's going to happen here is the nitrogen from our amine is going to grab a hydrogen from the water molecule. And we're actually going to end up with something called an ammonium ion. So we get this NH3R+. So by adding that extra hydrogen to our neutral amine, we've created a positively charged molecule or ion. And then what will be left over from water is the hydroxide ion, which is negatively charged. So as an actual example, we could start with methylamine. So we've got our methyl group and then our amine. And again, the nitrogen is going to grab a hydrogen from water, which is acting as our weak acid. And that's going to create something called the methyl ammonium ion. So when we add that extra hydrogen to nitrogen, it becomes positively charged. And then again, we're left with that hydroxide ion as a byproduct. In actuality, those two charged ions would team up together, but you get the idea. Okay. Now, amines will also behave as weak bases when they react with strong acids like hydrochloric acid. And they will form salts. So, for instance, if we have a primary amine again, but this time we react it with a really strong acid, like hydrochloric acid, the nitrogen is going to grab a hydrogen from hydrochloric acid to give us that positively charged ion again. And this time our other product is a chloride ion. So these two can team up together to create a salt. Now you might be wondering, why didn't we create a salt with the hydroxide ion? Well, salts are defined as ionic compounds that don't have hydrogen or OH. So basically the main components in acids and bases, right? So here, because we have a chlorine instead of a hydroxide ion, that's what makes it a salt, kind of like sodium chloride. All right, so if we react methylamine with hydrochloric acid, we get methyl ammonium chloride. And again, that will be our salt product. Now, one example of a biologically important amine is caffeine. Caffeine is found in many different drinks and foods. It's found in coffee, Coca-Cola, other soda, tea, chocolate, and cocoa. So I'm personally a huge fan of coffee, but caffeine is a drug. It's a mild stimulant, so it can make you feel anxious, but it can also make you feel a little more alert or awake. So it does have some side effects such as nervousness and insomnia. It's also a mild diuretic, which just means you have to go to the restroom more. But it can also be used in pain relievers, cold remedies, but it's also used in things like diet pills or I guess here they're calling them stay awake pills, but some people might call them uppers, for instance. But you'll notice down below we have the structure of caffeine, and there are a lot of nitrogen atoms in here. There's also actually an amide right here because it's next to these carbonyl groups. So caffeine does contain a lot of nitrogen. So yeah, if you've ever had a lot of coffee and then tried to stop drinking coffee, you definitely can have some withdrawal effects like a headache. You could have an upset stomach. So it is still a drug, so you do need to be careful with caffeine. All right, another biologically important amine group is the alkaloid group of molecules. So these are a class of nitrogen-containing organic compounds that are obtained from plants. So one example is nicotine. Nicotine is found in tobacco. So if you know someone who smokes, or if you smoke yourself, nicotine is present in cigarettes. In small doses, it is a stimulant similar to caffeine, and not especially harmful, but it is habit forming. So you could crave nicotine the more you have it. If you're addicted to nicotine, that could also expose you to other harmful substances like tars, carbon monoxide, and carcinogens, which are cancer-causing compounds. So you do want to be careful with nicotine as well. But notice here we do have those two nitrogen atoms in the molecule. Now let's talk a little bit about amide formation. So amines will react with either an acid chloride or an acid anhydride to form an amide. So this is very similar to how we formed esters. Now the amide linkage will be right between the carbon and the nitrogen on the amide. So that's what we're trying to form in these reactions. So let's look at some examples. Now, primary and secondary amines can form amides, but tertiary amines cannot form amides. So that's why it's important to know how to classify primary, secondary, and tertiary amines, because that's going to tell us whether we can form an amide or not. So down below, we have a reaction between an acid chloride and a primary amine. So this amine only has one alkyl group. And very similar to the reactions we saw for formation of esters, the hydrogen from the amine and the chlorine from the acid chloride will team up to create hydrochloric acid. And then the other components are going to team up. So the carbonyl carbon and then the nitrogen from the amine, they're going to create a new bond, that amide linkage. So we get our amide molecule. Now, you can also perform this reaction with an acid anhydride. So the hydrogen from the amine will team up with the second half here of our acid anhydride. And that's going to create a carboxylic acid, very similar to what we saw with the ester formation before. And then we're going to form a new bond between the carbonyl carbon and the nitrogen from the amine. So we end up with the same amide that we saw up above. All right. Now, we could also form amides using ammonia, which technically isn't an amine because it doesn't have any alkyl groups attached. It just has hydrogens that are attached. So that's another possibility, and then you'd end up forming, again, your amide and a carboxylic acid in this case because we started with an anhydride. Down below, we have another real-world example. If you start with something called benzoyl chloride, it basically looks like benzoic acid, so a benzene ring with that carbonyl group. But instead of an OH on the end, we have a chlorine. And if we react that with a primary amine, like methylamine, again, the hydrogen from the amine and the chlorine from our acid chloride team up to form hydrochloric acid. And then we form a bond between the other two. And this is going to form the amide shown in the products. And this is actually called N-methylbenzamide. So let's talk about all of the amine reactions that we've gone over so far. So we said that if an amine reacts with a strong acid, like hydrochloric acid, we get a salt. If the amine reacts with water, we get an ammonium ion plus OH minus. If the amine reacts with an acid chloride, we get an amide plus HCl. And if it reacts with an anhydride, we get an amide plus a carboxylic acid. So again, very similar to esters. Now, amides can also go through their own reactions. So amides are not acidic or basic, but one reaction we can perform with amides is hydrolysis. So this is just the reverse of amide formation, similar to when we talked about esterification and ester hydrolysis. They were just the reverse of each other. So in amide hydrolysis, what we're going to do is cleave or break the bond between the carbonyl carbon and the nitrogen on the amide. We're also going to add water. This is hydrolysis. And then you can use either an acid or a base as your catalyst to help the reaction along. And you'll add a little bit of heat as well. And you'll end up forming a carboxylic acid and an amine. So again, just the reverse of amide formation. Now, the reason this is such an important reaction is that amide hydrolysis is a very important reaction in the digestion of proteins and also in the breakdown of proteins within cells. So we'll talk more about that later on. Now, in our bodies, instead of using an acid or a base to catalyze the reaction, we would use an enzyme, which is a type of protein. Oh, and that is it. I thought I had a couple more slides, but I guess not. Okay, so we are done with chapters 15 and 16. Again, I'll post some flashcards with all of these different reactions so you can kind of keep them all straight. Again, some of the reactions are very, very similar, like esters and amines and amides. They all have very similar processes that they go through. So, you know, if you can just kind of get the basics down, like what happens if they react with water versus an acid or a base, then that will kind of help you remember all of the reactions. All right, if you have any questions, please feel free to message me on Canvas or through email or post in the discussion board on Canvas.